Plants are the foundation of life. They feed us, heal us, and keep our planet alive. But today, climate change and shifting seasons are disrupting their natural blooming cycles. Farmers cannot predict harvest, allergy risks are harder to track, and scientists struggle to monitor ecosystems. NASA already collects powerful Earth data, but there's no simple way to see when and where plants are blooming in real time. I wish there were a solution to these problems.
So, having issues? Say no more. We, the team Met Titan, have arrived with a solution. We have made a visualization tool named Vegetation Blooming Visualization.
Welcome to you all to our group of 6 amazing members. Let me introduce to you Team Matt Titan. This is our prototype plant bloom monitor. So it is built using the advanced monitoring with NASA Earth observations, weather correlation and AI power insights. So what we do, first we have to search a location. So suppose you don't know any location, so no need to worry. Here we have a map. You can view through the map, select any kind of location and it will show us the data info that we are looking for. So suppose we are gonna select Dhaka division, then we are gonna select the start date. Let's say we are going to select like September 30, okay, and the end date is today, which is 31 August 2025, and we have some option here like vegetation index. So what does this mean? We have 3 options like NDVI, normalized difference vegetation index, EVI, LAI, leaf area index. So we're gonna start with the NDVI. So NDVI means that it is a metric that uses satellite or remote sensor data to measure the health and density of vegetation by quantifying the difference between NIR reflectance and red light observation. So we selected our location, we select a start date and end date. Now let's see the analyze. So if you click the analyzation vegetation, here we can see a vegetation timeline and a seasonal pattern. So what the vegetation timeline shows, the vegetation timeline graph tracks the vegetation health in normalized difference vegetation index, which is NDVI, on the time overview of the 2024 to 2025. And here we have seasonal pattern. So seasonal pattern shows the average vegetation levels by month, summarizing the year's seasonal trend. So from the seasonal pattern we can see the highest average vegetation was in April, which is 0.889, and the lowest average vegetation is in October, which is 0.658. And here we have the result of our vegetation analysis. Here we can see the current vegetation index is 0.674. Trends means the change from the previous session. So the trend is minus 7.7%. The peak bloom month is on April 10th, and confidence means our accuracy of this data. So here we can export the data, share the data, or compare the data to any other location. Well, if you think that this information is not enough, then no need to worry. We have the advanced analysis option. So click on it and it will show us the 4 features like climate impact, pollinator activity, biodiversity hotspot, and weather correlation. So let's see the climate impact. It will show us the full details of a climate impact on the time period of 2015 and to 2025. It will show us the every details that you need to know. Then let's see the pollinator activities. It will also show us the details of a current date, which is 31/8/2025. And if you want to see the other details like biodiversity hotspot, click on it, and weather correlation, click on it, and it will show us the whole details of the biodiversity hotspot direction and weather correlation analysis. So this is our prototype, and it will show you every information you need related to plant bloom on a specific area. Thank you everyone.